Welcome to this special episode of Frequency Matters, the RF and Microwave Update Series. I'm Pat Hindle, and I'm here with special guest Elliot Fine, Product Line Manager, Space and High Reliability at Analog Devices. Welcome, Elliot.
Thank you. Excited to be here.
So the space market's been a very active area, so I thought it'd be great to explore the trends in this area. So what's going on in the space market that's exciting for the RF and microwave industry?
Yeah. So as you said, the market has grown significantly over the past decade, um, both in commercial applications and in government applications. We're seeing proliferation as a major trend across all orbits. That's both in comms and government satellites. A transition from large birds to small satellites in multi-satellite constellations with wider capabilities and ultimately more data throughput. So what this means that's exciting for someone in the RF industry is an explosion of radio opportunities. It's really all about the radio in space. So that means SATCOM gateway radios, feeder links, intersatellite links, radar, in-space maneuvering and refueling, tracking, telemetry, and control, and they all require radio and data processing for these applications. So it needs ubiquitous electronics and ultimately needs great alignment with ADI technology.
So what do all these radio opportunities mean for the RF and microwave suppliers?
Yeah, there are a few subtrends that are getting my attention at the very least. So phased array is central to this. The ability to process more data while maintaining a tight power budget, which of course is critical in space. You can't just go up and add more fuel. They need to maintain weight of the satellite and want to keep the battery packs and the solar panels as small as possible, especially as we move towards smaller satellites and more proliferation. We're also seeing emerging frequency bands, Ka, Ku, Q, and V. And then the increased data throughput means we need wider instantaneous bandwidth, and the breadth of frequency bands that we want to cover also means we need a wider bandwidth for our RF systems. So this all requires innovation of our RF signal chain, beamforming, and data converter components, and then the systems that will go into these satellites. So as a result, many suppliers, Analog Devices included, are moving towards more silicon-based RF solutions.
And so what are the advantage of the silicon-based RF solutions versus the traditional GaN and GaAs that's been favored in the past?
So primary integration is a great question. Primary advantage is integrating digital blocks into the design. This allows them to be more power efficient with things like programmable filters. Lookup tables make it faster and easier to reconfigure and tune in software. There are cost advantages because of the scale that we can get with our silicon-based RF processes. They're being used in other applications. Silicon is pretty ubiquitous in semiconductor manufacturing, as I'm sure you know. So this allows us to really ramp up our production in a way that the more niche GaAs and GaN processes couldn't. And when you have higher volume processes, you end up with better reliability, lower defect instances, as a result of the high volume production. There are certainly areas where it doesn't make sense, like RF amplifiers, imagers, where GaAs and GaN are still going to rule the day. But I think a lot of the RF signal chain blocks are going to transition over to silicon-based solutions over the coming years.
But GaAs is notoriously robust in space, though. So does the switch to silicon-based RF mean that the satellites will be less robust?
An excellent question, and something that we've been working on over the past few years, and I think our customers are paying a lot of attention to. So it's true that GaAs processes are inherently rad hard. Many are natively good out to a megarad of total ionizing dose. The reliability assurance and screening is still really valuable on these GaAs products, but radiation testing and radiation hardening is typically not needed. So for silicon, users depend on the designers and the suppliers of these devices building radiation tolerance into the design, which takes some intelligence and some expertise to be able to do well. Even with processes like SOI, silicon on isolator, which are better from an inherent radiation performance standpoint, you can still have cells and blocks within there that just fail or have significant failure mechanisms in under radiographic effects. So there's an increased dependency, I think, on suppliers who really know what they're doing and who have the know-how and the willingness to go out and design products that will do well in the space market. So I would say that's something that ADI, I think, can offer a lot of advantages to our customer, and a way that we're working to address the changing market.
And so what is ADI doing to address this change in the market?
So ADI broadly has a goal to lead the intelligent edge. We want to be, as with the increased data throughput that's required for trends like not only satellite proliferation, but also things like artificial intelligence. We want to lead that transition and provide the real world to bits connectivity that's required across the world right now. So we have an increased breadth of the RF portfolio. ADI has done a lot to expand its RF portfolio and doing a lot more in silicon. So there are many recent releases from ADI inherently, and then we have a lot of breadth of legacy portfolio in RF space, and we have a retooling of our portfolio that's coming out now with a couple of releases that have just started, and then more to come over the next months and years. That'll be on these silicon-based processes. So we are working on with industry-leading performance from an IP standpoint. We are designing with known good radiation performance because of our expertise in this market. We're taking commercial silicon IP. We'll often do unique die spins for improvements on total ionizing dose or single event effects. And then we validate these processes through our space screening flows, like commercial space low and commercial space high, which are targeted at the changing space market. So all of this combines to be, I think, a compelling story around who ADI is in the space market. We want to be the leading supplier for RF in space effectively, and I think we are well positioned to do that with the mix of our IP and our know-how in the space market. And we're trying to load as much information that can be helpful to our customers as possible up on the web. So at analog.com/space, you can find a lot of the details on what we're doing, and we will continue to post our new releases there.
Well, thank you, Elliot, for your insights into the RF and microwave space market, and hope to have you again back to give us an update. To our audience, you can find more videos at videos.microwavejournal.com. Thanks for watching.